Okay, this is note 62, and this is a spring final exam review. So number 1, here's just the factor completely. Now this is a quadratic expression. So remember that in quadratics, we can identify the a value, the b and c values. But there are some special cases, and this is one of them. In this quadratic, notice how I have a difference, there's a minus sign, and here I have two perfect squares. So x squared is the square of the sides x by x, and 49 is a square with sides of 7 and 7. So when you have a difference of two squares, you can factor directly from the original question into factored form. And so all we do is we use this x and 7 in both factors, and you can decide to put one as a positive and one as a negative case. And these will be the factors for this quadratic. Remember, you could always multiply things back together to check your answer. But if you think about what's happening here, 7 times negative 7, that does give you back negative 49. And then if you multiply 7 times x, that's positive 7x. And then negative 7 times x is negative 7x. So 7x minus 7x, those are opposites, they cancel. So that's why you end up with this original falling back if you were to multiply. 1b. So in this case again, if I look at the original problem, I see I have a minus sign, so it's a difference. And here again I have a difference of two squares. So difference of squares. R squared is a square that's an r by r square. So that's a perfect square. And 81 is a 9 by 9 square. So when I recognize this special product, I can go right to factored form. And again here it's going to be r and 9 in both of the factors. And I can decide to make one a negative and one a positive. Notice how you compare 1a and 1b. It doesn't matter which factor you would put with the minus and the plus first, as long as they're alternating. So one is positive, one is negative, then you have the right response. So in this case, the two factors to r squared minus 81 are r minus 9 and r plus 9. Number 2. So again here we're going to factor completely. So in this case, I have a generic quadratic here. Right, in standard form we can identify the a value, so here is 1, b is negative 5, and c is negative 14. And so we're going to factor by grouping here. So first, we'll start with the x factor. And remember that in this organizer, in the top section of the x, it's going to be a times c. So it's always your a times your c values. In this case, 1 times negative 14 is negative 14. So that goes here. In the bottom part of this organizer, it would be just your b value by itself. So your b number here is negative 5. That goes here. And then your job is going to be to think about what factor pairs of 14 can combine to make negative 5 in some way. So 14 is 1 times 14, and it's 2 times 7. So 2 and 7 can make 5 in some way, so I'm going to choose those and put into my x factor. Now for this to work, recall that I have to kind of play with the signs here so that these can combine to make a negative 5. So for that to occur, I have to make the 7 a negative. And if I check, 2 times negative 7 is negative 14, so that satisfies that part of it. And then 2 minus 7 is negative 5, so this works. So once we make this x factor work, we can then go into the grouping phase. So the whole point of the x factor again is to find a way to rewrite the middle term into two separate terms. So here's how that works. We'll take the original question. So here's the original n squared minus 5n minus 14. But now I'm going to take this original b term here, and I'm going to rewrite it as plus 2n minus 7n. And I took these numbers from what I found here in the x factor. Otherwise, the rest of it comes down the same. So n squared in front minus 14 in back. From here I can group my 4 terms into a group of 2 terms and 2 terms. So here's my group of 2 and my group of 2. And if I look at them carefully now, I want to find the GCF of each of the small groups. So first, in n squared plus 2n, these share an n in common, so I can divide that out. So I'm left with n and n plus 2. And then we learned that in this process, once you find the first parentheses, it has to be the same in the second group. So this n plus 2, I can just kind of pre-fill it in my second group. Then I have to ask myself, what's the GCF in the second group that will give me a result of n plus 2? So here, notice how they both have a negative sign, and they both have a 7. So if I divide by negative 7, then this will give me a result of n plus 2. At this point, I can then do one more division. I can divide out n plus 2 out of the whole thing. So I get n plus 2 as one factor, then n minus 7 as the other factor. And so I've now factored this quadratic. Okay, 2b. So again, we're trying to factor this quadratic. So first, identifying our a value of 1, b value of negative 15, and c of 56. So making the x factor, a times c is going to be 1 times 56 is just 56. And then my b number is negative 15, which goes here. And then 56, among other things, is going to be 7 times 8. So as you get better at this, you can just kind of do it in your head. And 7 and 8 here are going to work if I make them both negatives. If I check, negative 7 times negative 8 is a positive 56, so that works. At the same time, minus 7 minus 8 is negative 15, that also works. So at this point, I can take my original problem again, so I'll just write it here on the side. So w squared minus 15w plus 56. And I can take my original middle term, and I can now rewrite it into two terms. Minus 7w minus 8w. Again, I'm getting these numbers from the x factor. Otherwise, I have w squared in front still, and then plus 56 in the back. As I group these, I have a GCF of w to start. And here I can divide by negative 8. And this is a factor out. I will end up getting the same expression there in the parentheses. I expect that to happen. So then once I'm there, I get my factors of w minus 7 and w minus 8. And I factored this quadratic. 2c. So again, more practice. So first, a is 1, b is negative 6, and c is 27. So I'm the x factor. So here I'm going to put a times c to be 27. And my b number is negative 6. So at this point, 27 is 1 times 27, and it's 3 times 9. So in this case, as I start to factor this problem, I'm going to choose 3 and 9 because these have potential. Notice how in this example, for this to work, for me to get a negative 6 when I combine these two, I have to make the 9 negative. So 3 minus 9 is negative 6. That is true. But in this example, if I take those exact same factors and I multiply them together, 3 times negative 9 is negative 27. And that's not what I have here. So in this case, when you try to make the x factor work, it doesn't quite work. So what that means is that when this does not work for you, then you can respond that this is not factorable, or, sorry, that's really bad, guys, or that it's prime. So in the case where you can't make the x factor work, that just means that this particular quadratic is not factorable, and that's okay. Remember that we have other techniques to solve, like the quadratic formula, when you cannot factor something. Okay, 2D. So again, factoring this quadratic. So here, a equals to 1, b is negative 16, and c is 64. Now again, in this case, a times c is going to be 64. The b number is negative 16. And here I know that 64 is 8 times 8. And in this case, if I make them both negatives, this does satisfy the x factor. Now, one thing that we talked about in class before was, we talked about some special cases. Now, for this particular example, in fact for all 4 of these, we did mention that when a equals to 1, it's kind of easier to factor because once you do the x factor, if it works, then you can just go directly to your response where you have your variable and then the numbers you found here in the x factor. So in this case, when a equals to 1, then you can jump from the x factor to your factored form. There's no need to do the grouping. If you look at examples above, we did a lot of work there, but you could have gotten the answer from the x factor. So in this case, when a equals to 1, you could go from the x factor to your factored form. And in this example here in particular, if you have the exact same factor repeated, so x minus 8, you could also write it as x minus 8 quantity squared. So just kind of be aware of that. Alright, number 3. So now that we've factored a couple of examples, now the goal is going to be to solve quadratic equations. So when we solve with quadratics, we have different methods that we talked about in class. Factoring is one of them, but it doesn't always work. Taking square roots is another technique. Again, doesn't always work. And then we talk about the quadratic formula, which always works, but it's just a little bit more involved. So in this case, if I look at this quadratic, and again, this is from experience, but this to me looks factorable. So I'm going to attempt to solve this using factoring. So, like we did above in numbers 1 and 2, let's factor this quadratic. So here a equals to 1, b is 5, c is negative 6. So if I x factor, here I get negative 6 and positive 5. And then 6 is 1 times 6, so if I make the 1 negative, this actually does work. Again, minus 1 times 6 is negative 6, and minus 1 plus 6 is 5, so it does work in both cases. So again, if a equals to 1, once I make the x factor, I can jump right into factored form. So here, to factor, I can skip through the grouping piece because it's not needed when a equals to 1. I can go to x, and then I can just use the numbers that I found of minus 1 and 6. And I factored this quadratic. So now that it's in factored form, I can solve from factored form. Remember that when I do this, I'm going to let each factor equal to 0. So either x minus 1 equals 0, or x plus 6 can equal 0, because they're both going to solve the equation. So again, set each factor equal to 0, and then just solve, and that'll produce your answers. So first, here I can add 1 to both sides, and I find that one answer is x equals to 1. Next, I can here subtract 6 to both sides, and find that my other answer is going to be negative 6. Okay, 3b. So again, I want to solve this quadratic equation. Now in this case, this looks a little bit suspicious here, so I'm not sure I can factor. So when I'm not sure, I'm going to attempt to use the quadratic formula. Because when I use the quadratic formula, my first step is to find the discriminant, and that's going to tell me what I can do with this question. So again, I still need to know my a value is 1, b is negative 15, and c is negative 44. So in this case, I'm going to first find the discriminant. Again, the discriminant is a piece of the quadratic formula. It's b squared minus 4ac. Now, that might look a little bit scary, but if you think about it, it just requires me to know an a, a b, and a c value. And I already have those in my equation above. So I'm just going to input those values where they belong to find this value. So here, b squared, b is negative 15, so I'll put that in here. Minus 4 times a is 1, so I'll put a 1 there. And then c is negative 44, so I'll put a negative 44 in there. Now for these questions, you guys have calculators, so please use them if you need them. Here, negative 15 squared is 225. And then negative 4 times 1 times negative 44, altogether is going to be positive 176. So if I add these together, I get 401. Remember that when you find the discriminant, this is not a solution. This is just a piece of the quadratic formula. But this value tells me two facts about my quadratic. One, because it's a positive value, I'm going to have two real solutions. And second, because 401 is not a perfect square, this is not factorable. So I couldn't factor this if I wanted to. It doesn't work in this case. It's okay though. I'm going to solve now with the quadratic formula. I'm going to now finish this up. So the formula is x equals negative b plus or minus the square root of the discriminant all over 2a. So here it's negative b. Again, b is negative 15, so it's a negative 15. I'm just inputting right now. Plus or minus the square root of the discriminant. But we just found that discriminant, so that we already have that number. That's why it's a little bit easier. All over 2 times a here is 1. So from this stage of the problem, I'm going to just work this out. So then I get a negative times a negative here is a positive 15. Plus or minus the square root of 401 all over 2. Now at this point, because this does not break out to anything smaller, I can stop here with my response. If you wanted to, which is not going to be required to be on the final, you could get a calculator and get some decimal responses with this. But for our purposes, I'm going to stop here with the response. Alright, 3c. Let's solve this quadratic. Now, if you look at 3c compared to the other two previous examples, this is not in standard form. So in this case, if I look at it carefully, I can actually solve this equation to get x by itself. So I'm going to solve this quadratic by taking square roots. So that means I'm going to just solve the equation. So first, I'm going to add 3 to both sides. So now I have x plus 7 squared equals 3. Next, I'm going to cancel the square by taking the square root of both sides. So the square root cancels the square. And I'm left with x plus 7 equals plus or minus the square root of 3. And to finish, to move this plus 7 over, I'm going to use minus 7. And so I get x equals minus 7 plus or minus the square root of 3. Again, at this point, you can get a calculator if you wanted to get to your 2 decimal responses. But again, that won't be required of you for this at this point, so you can leave it with radical response. 3D. Again, if I look at this quadratic, this is not in standard form. And if I look at it carefully, I can also solve this for x by simply taking square roots. Or by solving the equation, and then at some point taking a square root to isolate your variable. So, let's give it a go. Minus 10 to both sides. So I'm left with x minus 1 squared equals negative 10. And again, here to cancel the square, I'll take a square root. What's to do with x minus 1 equals plus or minus the square root of negative 10. And to finish, I'm going to add 1 to both sides. So I get x equals 1 plus or minus the square root of negative 10. Now, in this example, when we have a negative and a square root, we really can't deal with that with our real numbers. So in this case, I can say that I have no real solutions. But, sorry guys, I came out really poor. No real solutions. So that would be a correct response for this problem. However, if you wanted to take it one step further, we did mention in class the idea of imaginary numbers. So here I could take this response and I can write it as 1 plus or minus, and we talk about the negative and radical comes out as an I. So if you chose to write it this way, then you would have your complex solutions. Okay, so just be aware that you have two options here. You can keep it in the real number system and say no real solutions, or you can go complex and take a negative out of the square root with the I number. Alright, 3e. Again, we're still just solving quadratics. In this case, this is back in standard form. So I can identify a is 4, b is negative 3, and c is 5. Here, again, I cannot take square roots because I cannot isolate x by itself. So I'm either looking at factoring or the quadratic formula. And at first glance, I'm going to give the quadratic formula a try, because I know this is always going to work, and I'm not sure if I can factor. So I'm going to find the discriminant. So it's b squared minus 4ac to start. So if I do that, here I can input b squared, so b is negative 3 squared minus 4a and c. If I work this out, negative 3 squared is 9, and negative 4 times 5 is going to be negative 80. And again, if you need to calculate, that's fine. So 9 minus 80 is equal to negative 71. Now, in this case, when your discriminant is a negative value, you know at that moment that you're going to have no real solutions. So on the final exam, you could stop right there and that's your response. However, if you wanted to take it a little bit further, we could still keep going, knowing that we have complex solutions. So just to practice that, I could take the quadratic formula, so x equals negative b plus or minus the square root of the discriminant all over 2a. And here, x equals negative b. Remember, b up is negative 3 in the beginning. The discriminant we found to be negative 71, and all over 2a. So I could choose to work this out further and get here 3 plus or minus the square root of negative 71 over 8. And then one last step would be 3 plus or minus I square root of 71 over 8. So you could choose to find complex solutions, but again, for the final exam, once you find the discriminant, if it's a negative value, then you can say you have no real solutions. Okay, 3f. Again, we're still just solving quadratics using whatever method we want. Again, in this case, I'm going to try with using the quadratic formula. Remember, if all else fails, this always works. So first I'm going to identify a to be 1, b to be 4, and c to be negative 6. And I'm going to find the discriminant b squared minus 4ac. That's a 4, sorry about that. So again, here it's b squared, b is 4, so that goes there. Minus 4 times a is 1, so 1 goes there. And c is negative 6. So now I work this out. 4 squared is 16. And then negative 4 times 1 times negative 6 is positive 24. So here my discriminant is going to be 40. So again, that's a positive number, so I'm going to have two real solutions. And 40 is not a perfect square, so I could not factor this anyways. So I go to my formula. So x equals negative b plus or minus the discriminant all over 2a. So x equals negative b, b here is 4, my discriminant is 40, and a equals to 1. So as I work this out, I get negative 4 plus or minus the square root of 40 over 2. Now this is a correct response so far, but in this case we have to always consider if we can simplify the radical in the problem. And if you look at 40, 40 is going to be the same as saying 4 times 10. So if I simplify 40, just the square root of 40, it's 4 times 10. Well, basically, if I think of that as a square root, I know that the square root of 4 equals to 2. So I can rethink this as 2 radical 10. I'm just talking about the square root of 40 piece. So I still have negative 4 plus or minus, and all over 2. So if I can simplify this out, I need to do that. At this point, if I scan my 3 terms, I have a negative 4, a 2, and a 2. So I can do one more thing here and simplify every term here by 2. So I end up with negative 2 plus or minus the square root of 10. And that's going to be my simplified answer for this problem. Again, at the end here, I just reduced every term here by 2. So divided negative 4 by 2, and then got rid of these 2's out, which is why I'm left with negative 2 plus or minus radical 10. Okay, 3G. So in this case again, I'm going to give the quadratic formula a shot, just because I know it's going to work. So here A equals to 5, B is 2, C is negative 1. So doing the discriminant, B squared minus 4AC. So again, B squared, so B is 2 minus 4AC. And this results in 4. And then negative 4 times 5 times negative 1 is plus 20. So I get a discriminant of 24. And again, that means I'm going to have 2 real solutions. So now with the formula, x equals negative b plus or minus the square root of the discriminant all over 2a. So here, x equals negative 2 plus or minus the discriminant all over 2 times a. So I'm just taking values from the original problem and my discriminant to fill into the formula. As I clean this up, I end up getting negative 2 plus or minus the square root of 24 over 2 times 5 is 10. But 24 I can think of as 4 times 6, and so if I rethink that square root as 4 times 6, the square root of 4 I know equals to 2. So I can rewrite that as 2 radical 6. So now I have negative 2 plus or minus 2 radical 6 over 10. And then at this point I can do one last thing. Notice how in all 3 terms they each have a 2 in common, so the G sub of 2. So if I divide them all by 2, kind of like this, I end up with x equals negative 1 plus or minus the square root of 6 over 5. And that's going to be our response for 3G. Alright, number 4. So now that we've solved quadratics several times, we want to practice graphing a parabola from vertex form. So in this case, this is again vertex form. Remember that in this form we can identify our A value, our H, and our K value. And in vertex form, we can find the vertex, which is our turning point of the parabola. So here A equals to 1, so that when we know our A value, we know that we're going to have our shape and orientation. So I expect to have a U shape. And then our vertex is going to be the point HK, which we can just identify from the equation. So remember that H is the one that's tricky. It's the opposite of what you see. So if you see a plus 2, you're going to choose a minus 2. Then K here is just at face value negative 3. So we can very quickly identify the vertex, negative 2, negative 3, and plot that point here on the grid. So negative 2, negative 3 is going to be here. On that point, we have our line of symmetry. Remember that we know that this U has symmetry, so it's going to fold onto itself. And so now what we have to do is we have to identify 2 additional points that we can reflect to get a good clean graph. So for this we use a table. So in this table we have our input and our output. And we'll place the vertex here, negative 2, negative 3, in the center of our table. And then you get to decide if you want to find 2 additional points to the right of your vertex, so using negative 1 and 0, or to the left using negative 2 and negative 3. So that's your choice completely, but we want to try to find the easier values, and typically if you have a 0 and a 1, it's easier to work with those. So in this case, I'm going to choose to work with these two additional points. So I need to use x equals -1 and 0 as inputs into this function to find these outputs. So first, I need to find g of -1. So I'll do that first here. So I'll take my original function, I'll copy it again, but I'll leave the x empty so I can input into it. So I get equals x plus 2 squared minus 3. And I'm going to input a -1. Then I work it out. 2 minus 1 is going to be here just 1 squared minus 3. 1 squared is 1 minus 3. That's minus 2. So that's going to be my output. So the point -1, -2 is also part of my graph. That's going to be here on the grid. Lastly, I need to find g of 0, which is my other input in this case. Okay, I'm going to copy the original function, leaving x kind of out of the way, so I can input 0 into it. And I work it out. 0 plus 2 is 2, 2 squared minus 3. 2 squared is 4 minus 3, that equals to 1. So g of 0 equals to 1, so then I have the point 0, 1, which is going to be here. So once I find two additional points, I can reflect them over the line of symmetry, and then just like that, I now have my graph. Alright, number 5. So 5 is just like number 4, so I'm not going to show you all the work for number 5, but I'll give you kind of the highlights of the problem. In number 5, again, this is vertex form, so I can identify my a value of 1, my h of 1, and my k of 4. So a being equal to 1, I expect to have a graph again that's going to open up. For my vertex, it's going to be the point 1, 4. So 1, 4. So plotting that point directly, 1, 4 is going to be here on the grid, and I have my line of symmetry. So notice if I just wanted to sketch this graph, knowing the vertex and the shape of my graph, I could just kind of sketch it quickly like this. Right? I expected it to open up like that. But I'd want to find two additional points. So again, to be precise here, my input on my output is x and f of x. I could place my vertex in the center of this table. And then here, I would choose to work with 0 and -1 to find two additional points. Now in this case, again, this is like number 4 above, so if you wanted to see this worked out more calmly, you can look at number 4 as a guide. But here, if I were to input these two x values, I'd output a 8 and 5. So then I can find these two additional points quickly. If I plot -1, 8, -1, 8 is going to spill off my grid a little bit to be about here. So it's about here. I'm just going to kind of guess. And the point 0, 5 is here. So notice how if I plot those points and reflect them, then again, there's a more precise graph for number 5. Alright, number 6. So now we're into the part of the review talking about right triangle math. So 6a and b ask you to find the value of the trig ratio that's given to you. So in this case, here's a picture of a triangle with 3 sides given to you, and I want to find cosine of c. Remember that when we do this c here is the angle that we're using here. So this is our angle in this case, our reference angle. So cosine of c means that I'm going to choose this acute angle c as my reference, so I can label my sides off of that angle. So first, 17 is the hypotenuse, and then from angle C, the side opposite is going to be the 8, so I'll put an O for opposite. Then 15 is the adjacent side. And recall that for all these questions with right triangles here, we can use SOHCAHTOA. So I would get in the habit of writing this out if you need it, so you can then remember what each of the ratios are. In this case, using cosine is going to be adjacent over hypotenuse. So here I can write the answer. Cosine of angle C, which is given to me, is adjacent, which is 15, over hypotenuse, which is 17. And I found that trig ratio for 6a. 6b, so here I want to find tangent of a. So again, in this case, this is my angle. It's going to be angle A. That's my reference angle. So I'm going to mark that here first. Next, I'll label my sides off of this angle A. So here's my hypotenuse. From angle A, the side opposite this angle is going to be 15. So that's my O for opposite. Then A for adjacent. Again, in this case, if I'm using tangent, tangent is always, it's TOA in SOHCAHTOA, so it's opposite over adjacent, O over A. So here's my answer. Tangent of angle A equals opposite, which is 15, over adjacent, which is 8. So that's the trig ratio for 6b. Number 7. Here it says find the measure of the indicated angle to the nearest degree. So here in 7a, I'm looking for this missing angle. So I'm going to choose that as my reference angle and identify my triangle's hypotenuse, opposite, and adjacent. And then in this case, again, thinking about SOHCAHTOA, so write it down again for you so you can see it. Notice how in this problem, how the adjacent side has no value for me. So here, it's not really usable for my computation, so I'm not going to use the A. But I can use opposite and hypotenuse. So OH is going to be sine. So here's my setup. Sine of my missing angle, so I'm going to just call this X. So I'm going to call this X equals opposite 14 over hypotenuse. So now that I have my equation, I need to get X by itself. So to cancel sine, I'll multiply by the inverse of sine to both sides. So then these cancel, X comes out free and clear, and equals to the inverse sine of 14 over 16. And then with your calculator, you can just press those buttons, and you get X equals approximately 61 degrees. So we found the missing angle. Okay, 7b again, here I want to find this missing angle. So again, we'll call this X again so we can see that. So again, using SOHCAHTOA as reference. Here, if this is my reference angle, then this is my hypotenuse. The side opposite my angle is going to be this blank side, and this is adjacent. So in this example, here the opposite side has no value, so I can't use that, but I can use the adjacent, the hypotenuse. So AH is going to be cosine. So cosine of the angle that I don't know yet, so cosine of X equals adjacent over hypotenuse. So to solve this equation, I can multiply by the inverse of cosine to both sides, and I get X equals to inverse cosine of 48 over 55. And with the calculator, that's going to be approximately 29 degrees. So we found this angle to be 29 degrees. Okay, number 8, find the missing side. So for missing sides, again, we're going to use SOHCAHTOA here in example A. So keep writing that over and over again so you can see it. Hopefully it kind of sticks. So in this case, I'm going to first pick my reference angle of 61 degrees. Once I have that, I have my hypotenuse, my opposite and adjacent sides. So in this case, to solve for this X, notice how in this case the hypotenuse has no value, so I'm not going to use that. So I will use opposite and adjacent. So that's going to be tangent. So tangent of 61 degrees is opposite over adjacent. And here I can solve this equation by multiplying by 12 to both sides. And that from here, this is the job of the calculator. Just type that in, and X equals approximately 21.6 units. And to my nearest tenth, it's 21.6. Okay, 8b. Again, here looking for this missing side. So again, here's SOHCAHTOA again. Here's my reference angle. Then my hypotenuse. My opposite side over, again, opposite of 52 degrees, and then adjacent. In this one, the adjacent side has nothing for me, so I'm going to use here opposite and hypotenuse. So that's going to be sine. So sine, sorry guys, that came out kind of weird. Sine of 52 degrees equals opposite over hypotenuse. And to solve this, I can times by 16. Then on the calculator, I can press all this in. This will be approximately 12.6 units. Okay, 8C, so 8 continued. Again, here looking for a missing side. So SOHCAHTOA one more time. Again, picking my reference angle, identify my hypotenuse, my opposite side, and my adjacent side. And so in this case, and notice how in this example, I can't use the opposite side. There's no value for me, but I can use adjacent and hypotenuse. So AH is going to be cosine. So I can write cosine of 17 degrees equals adjacent over hypotenuse. Now in this problem, I get a proportion which I can solve using cross product. So I get x cosine of 17 equals 1 times 20 is 20. I can divide both sides by cosine of 17 to isolate x. So x equals 2, and then at this point, all of this is just typed into the calculator. And if I do that, I get approximately 20.9. So this missing side is 20.9. And in regards to the triangle itself, remember the hypotenuse is the longest side, so I know it has to be more than 20, so that looks reasonable to me. Okay, 8D. So again, looking for a missing side here. So first, reference angle, and my hypotenuse, my side opposite my angle, and adjacent side. So in this example, the hypotenuse has no value, so I won't use that one, but I can use opposite and adjacent. So OA is TOA. So I can write tangent of 28 degrees equals opposite over adjacent. And again, in this example, this is a proportion, so I can use cross product. Again, x tangent of 28 equals 1 times 18 is 18. To finish solving for x, I can divide by tangent of 28 to both sides. So those cancel here. So x equals 2. And again, as before, on a calculator, if I put 18 divided by tangent of 28, I'll get approximately 33.9, which is the length here of this missing side. Alright, number 9. So number 9 says, find the missing side lengths using special right triangles, either 45, 45, 90, or 30, 60, 90. Leave your answers as radicals in simplest form. So in these 4 examples, they're all going to be special right triangles. So in 9a, if I see here a 60 degrees, this angle here is going to be a 30 degrees. Notice how in the examples here, you're also given multiple choices. So to practice picking a right answer, you have these 4 examples to try doing that. Let me zoom in for a second. So for 9a, this is a 30, 60, 90. So this is a 30, this is a 30, 60, 90 triangle. And the note for this triangle is that the sides comparative ratio of 1 to radical 3 to 2. So what that means is that in the 30, 60, 90, the hypotenuse is always twice as long as the short side. So in this case, to find these 2 missing sides, you're given the hypotenuse in this case. This 16 is across the 90 degrees, so it's linked to 90, so it goes here in the chart. You're trying to find 2 shorter sides. So to do that, if you're given this 16 as the longest side, and the short side is half of 16, 16 divided by 2 is going to be 8. So I can find the short side to be 8. So V equals to 8, just like that. Remember the logic is if you have a larger number, you're going to divide down. You're going to divide to find a smaller number. So here, 16 divided by 2 will give us the shortest side of 8. Now to go from the shortest side of 8 to the middle length side, I'm going to multiply back up by this factor. So 8 times radical 3 is just 8 radical 3. And that's going to be the length of our middle length side. So with that being computed now, we found our values. If I just go to the choices, please be careful when you choose on the final exam that you choose, I guess, carefully. So here, they give us the u value first, so u is 8 radical 3. So you scan your answers. Here it's 8 radical 6, so it's not going to be that one. Here it's 8, so it's not B. Or our u is 8 radical 3, so here it is for C, and then see how D it's not there? So here I can eliminate everything else besides C. If I compare it, u is 8 radical 3, V is 8, and that's what this has here. So 9A, the answer is C. Okay, 9B. Again, this is another special right triangle, and again, this is a 30, 60, 90. So I can write that down as my note. So it's a 30, 60, 90. So I know I have the ratio of 1 to radical 3 to 2. And in this problem, I'm given this 3. So this 3 is opposite to 30 degrees, so they're connected here. So I'm going to place it under the 30 degrees here in the chart. And I'm looking for 2 longer sides. So when I'm looking for longer sides, I'm going to multiply up. So in this case, to find the middle side across 60 degrees, it's 3 times radical 3. So 3 times radical 3 is just 3 radical 3. So I very quickly find that n is 3 radical 3. And then to finish, to find the hypotenuse, if it has a 1 to 2 ratio with these outside numbers, that means that this hypotenuse is twice as long as this shortest side. So multiplying up, 3 times 2 is 6. And I find my hypotenuse to be 6. So again, with those answers, I now have to scan my choices. Here, I'm given M first, so M is 6. Notice how A and B already fail, so it's not A or B. But in this case, C and D both have M equal to 6. But we found that N is 3 radical 3. So in this case, C again happens to have the right choice for us. So in this case, 9B also equals to C. Alright, 9C. In this example, this is a 45, 45, 90. And we learned that in a 45, 45, 90, the sides compare the ratio of 1 to 1 to radical 2. More specifically, we learned that in a 45, 45, 90, if we have 2 equal angles, we must have 2 equal sides. That's where the 1 to 1 ratio comes from. In this example, you're given this 10, which is across 45 degrees. So in the chart, I'll put the 10 with one of the 45s. But the moment I do that, I know that this other side here is going to be also equal to 10. So just like that, I found that B is 10 in this case. To finish, I need to find the longest side, the hypotenuse. So here, to find the longer side, we multiply up. So 10 times a factor of radical 2 is just 10 radical 2. And so I found that A equals to 10 radical 2. Again, with these two answers being found, I want to now pick correctly. So here, A is 10 radical 2. Notice how only B and C have that choice. So A fails and D fails. But I found that B is 10, so the answer is going to be B. A is 10 radical 2, B is 10. So in this case, I would select B for question 9C. Alright guys, to finish it off, this is now 9D. So in this case, again, I see a 45, 45, 90 special right triangle. And so if I give you the note again, 45, 45, 90, the sides compared to 1 to 1 to radical 2 ratio. In this problem, I give you 2 radical 2 across the right angle. So this is the longest side. So I'm going to put it here with the right angle, so 2 radical 2. And I'm trying to find the 2 shorter equal sides. So look at your 4 choices. Do you see how they're all equal? So that all makes sense. That's good. We have to find what it is. And the logic here is if I have a longer side, I want to find a shorter side, I'm going to divide down. So I'll take my given value of 2 radical 2. I'm going to divide it by this factor of radical 2. And in this case, the back just cancel out. So I'm left with just 2. So I can quickly find that the 2 sides here that are missing are both equal to 2. So that's going to be A. Because with that, this is the final exam review. Please look over whatever you need and ask whatever questions you need to ask. And if you need additional examples of any of these topics, you can always ask me in class. You can always do more kind of on the fly. Good luck, everybody.